بسم الله الرحمن الرحيم. نستكمل المحاضرة الثانية من مجموعة محاضرات تصميم مضخات الحريق طبقا لتوصيات NFPA 20. تعتبر هذه المحاضرة السابعة لطلاب الساعات المعتمدة والمحاضرة الثامنة لطلاب الفرقة الرابعة. Chapter 3 Centrifugal Pumps. Centrifugal pumps shall be of the overhang impeller between bearings design. The overhang impeller design shall be closed coupled or separately coupled single stage or two stage in suction type or inline type pumps. The impeller between bearings design shall be separately coupled single stage or multi-stage axial horizontal split case type or radial vertical split case type pumps. Application: centrifugal pumps shall not be used where static suction left is required. So it means a static suction head should be provided, as will be shown in next slides. Factory and field performance. Pumps shall furnish not less than 150% of rated capacity at not less than 65% of total rated head. The shut-off head shall not exceed 140% of rated head for any type pump. Fittings. Where necessary, the following fittings for the pump shall be provided by the pump manufacturer or an authorized representative. 1. Automatic air release valve to prevent air from water passage inside the piping system and the pump. 2. Circulation relief valve to protect the pump and the discharge line from any maximum pressure expected due to shutting down of the system components on the discharge line. 3. Pressure gauges to read and monitor the pressure on both suction side and discharge side. Where necessary, the following fittings also shall be provided. 1. Eccentric tapered reducer at suction inlet to adapt suction line diameter to the suction flange diameter according to the manufacturer design. Number 2. Hose valve manifold with hose valves to metering and test the pump performance and its flow rates according to each hose valve ratings and amount of flow to be discharged through it. Number 3. Flow measuring device to monitor and meter the flow discharged from each pump separately. Number 4. Relief valve and discharge cone. The discharge cone will adapt the discharge flange diameter to the designed diameter of the discharge line per each pump. Also, relief valve should be provided between the non-return valve and the discharge flange of the pump to protect the pump from any expected maximum pressure to be happen in this short lengths. Number 5. Pipeline strainer, which is recommended in some cases to be added into the suction side to ensure the water purity in the suction line. Automatic air release pumps that are automatically controlled shall be provided with a listed float operated air release valve having half-inch minimum diameter discharged to the atmosphere to prevent the air pockets from the discharge line and the pump casing during the pumping operation. This slide comparing between horizontal double suction pump and vertical double suction pump. On the left side, the upper one is a horizontal double suction pump where the shaft is located here horizontally, and this is a plan, and the impeller is affixed on the shaft, and this is the datum of the elevation of center line of the pump, and the flow as the suction is divided in both eye of the impeller, and according to the rotational motion of the shaft the impeller will rotate and to discharge the flow during this and through this volute casing from its smallest size until reach its maximum size at discharge flange. Also here in this vertical shaft the impeller is affixed on this shaft, and the bearing is supported with two bearings, one on the base here and one on the top, and the discharge of the impeller is from the suction flange is divided in both eye of the impeller from this side and from this side, half of the Q from here and the other half from here, and due to rotational motion in vertical direction of the shaft the impeller will rotate and collect the water in this volute casing until reach its maximum diameter in discharge diameter flange at the outlet and the discharge flange of the pump. The center line can be considered of this impeller can be considered as a datum level to be used as shown in this graph to evaluate the total suction head on suction side of the pump from the free water surface to the datum of the center line, and also the free water surface of the discharge tank to the same datum, which is the center line of the pump. And there are two pressure gauges are connected to the suction flange, the firstly, and second one is connected to the discharge flange to monitor and to meter the pressure on each side of the pump, and then we can evaluate the pump head of this pumping system. The free water surface is located here, however the total static head is here after adding the velocity head due to in suction line due to H velocity in suction according to the suction velocity of water inside suction line. The same also the additional term of velocity head to be added to the static term of total static of the static discharge head to get the total discharge head, which is equal the H velocity of the discharge line plus the H static discharge. So then we can evaluate the total head required for this pumping system from this level up to this level. This is the total head, which is the difference between the total discharge head minus the total suction head, which is named total head of the pump after adding both a static term and dynamic term due to velocity head on both sides suction and discharge lines. This slide presents two diagrams. The first one on the left hand side is a photo cutaway for horizontal Splitkey single stage double suction pump. The shaft is affixed here horizontally with two bearings located here and here, and this is the end of the pump, and this is discharge flange, and this is the impeller affixed, which is affixed with its both eyes of this impeller from both sides at the flow and the suction side divided on these both sides of the impeller eyes, and then according to the rotational motion of horizontal shaft the impeller will rotate also and collect the water in the volute casing, which increasing in this direction until reach the discharge flange of the pump as shown here. And this is the base of the pump, and this is the body of the pump affixed securely with these bolts to the base as shown. Also here we can see this construction details drawings for the same horizontal shaft and its bearings from both sides as mentioned before, with the grease lubrication is here, and stuffing box, and the impeller finally is affixed and feathered key with feathered key to the shaft of the pump, which will be feathered key also from this side to the pump driver, even electrical motor or diesel engine, and then the flow will distributed equally on both eye of the impeller from this side and this side, and according to the rotational motion of the shaft the impeller will rotate to collect and get the flow out from its outer diameter and to be collected in this volute casing, which increased from its smallest size until reach its maximum size at the discharge flange. This slide comparing between two family curves for peerless pumps, AS series of horizontal split case single stage double suction pump. The left hand side shown the AE series range chart at 1750 RPM when using two pair of pole motor at 60 Hz. The curves are given in both units, SI units and bridge system units. Between the head or the pressure in feet in this direction and in meter in this direction, and the flow in GPM in the bottom and the flow in meter cube per hour on the top. The same this graph but for 3550 RPM for one pair of pole motor with 60 Hz. However, it will gives 2950 RPM with 50 Hz as here in Egypt. Both sides of head in feet and in meter are the same, similar to the first curve, and the flow in GPM and meter cube per hour. So for example, if we have the pump discharge 500 GPM with 300 feet, so our operating point will be located here as shown with this marking point on, which is included on an HQ curve located somewhere here, but this curve just gives us the family name and the construction and the model type of this pump, and we can get to study the HQ curve of this pump carefully in each separate and specific HQ curve on the catalog later on. On next slide we will present. It also should be cleared that for all fire pumps used using one pair of pole of motor at high speed. So in fire pumps we use this set of family curves, and this set of curves we don't use for fire pump, but we can use it for irrigation or HVAC chilled water pumps or hot water pumps. So we in fire we always use this high speed using one pair of pole motor at 50 Hz, which gives us 2950 RPM. This slide also presents the construction details drawing for horizontal single stage split case pumps with double suction impeller, as can be seen with all its components such as bearings, stuffing box, impeller, shrouded case rings, case assembly, and oil lubrication as optional. And on the left side we can see the pump from outside and its casing, but it colored with blue, which is not commonly used in fire, but it can used for portable water or for irrigation or for chilled water of HVAC system. However, for fire pumps we always use the red color for the pump casing from outside, and the pump should be UL and FM approved. This slide also comparing between the pump classification based on casing type. The left side photo showing a split casing pump with double suction impeller. However, the case is uh, removed to upward to show the pump components from inside, such as the shaft of the impeller and the packing and the casing and the packing from the other side. However, the right hand side figure showing an end suction pump, the shaft is installed horizontally here and the impeller is affixed perpendicular on it, and this is the suction flange with the suction flange bolts from here, and this is pressure tab, and then the flow go through the impeller eye of single suction single stage impeller, and then according to the rotational motion of the shaft in this direction, the flow is collected and discharged after discharges from the impeller outlet to the volute casing until reach the discharge flange, which is located here perpendicular to the suction flange. So in suction type, the suction flange and discharge flange are commonly perpendicular to each other, as listed before in previous lecture. This slide presents also the affixation of the horizontal split cases and its coupling with electrical motor drive on left hand side. The coupling is covered by safety shroud or safety guard, and the fire pump have its hook from its top, and also the motor, and both of them are affixed on the same base. On the right hand side we can see the impeller affixed to the shaft and the packing gland and the clearance ring and the clearance ring from other side, and the eye the impeller, and its edge of the impeller is located here between these two shrouds of the impeller. In this figure we can see how the volute casing increasing in the flow direction, and this is a particle of flow which can be traced from here to be discharged from the eye, how it can go through the impeller vein, between impeller vein, until go throughout the impeller and then go through the volute casing to be discharged outside of the pump from its discharge flange. This is configuration is for end suction type pump. Here this slide showing overhang impeller for closed couple single suction stage end suction pump. This is suction flange and this is the impeller is located here. All the number is shown below the figure, and the shaft which is feathered to the key or bolted here with the impeller eye, and this is the volute casing, and this is the discharge flange, and this is the closed coupling which is hidden here between the short pump casing and which is closed coupled to the electrical motor with its shaft which is go this way, and this is center line of both the electrical motor and end suction type. However, this tableau is showing the horsepower and locked rotor current motor designation for NEMA design B motors for each horsepower starting from 5, 7.5, 10, 15, 20, 25, 30, 40, 50, 60, 75, 100, 125, 150, 200, 250, 300, 350, 400, 450, 500 horsepowers motors and its locked rotor current if using 3-phase 460 volt, the ampere needed for these horsepower motors, and this is the motor designation with rotor locked rotor ampere, indicating also the code letter starting from JHG as can be seen on this table to be helpful during selection of the electrical motor and its power supply and cabling sizing of this electrical device. This slide presents the right and wrong pump sections. We can see the right configuration of the eccentric reducer, the flat side should be on the upper part between the connection between the suction flange of the pump and the suction line, where the flow coming from this diameter and to be reduced to this diameter, which is designed by manufacturer. So we have to adapt, but keeping this line is straight to avoid air pocket, as it can be seen here in this wrong arrangement if using concentric reducer instead of eccentric reducer. Also, it's not recommended to use this elbow in suction side to prevent the separation due to this elbow configuration and flow pattern in the suction side of the pump. In this graph we show the horizontal end suction fire pump with all construction details numbered here, and as shown on this figure, and this suction flange and this discharge flange, and this is the impeller affixed here, this is the shaft and its bearing and packing located here, and how the shaft is affixed to the impeller, and these bolts to close the casing of the end suction pump, and all the rings and covers and packing and sleeves and glands are mentioned here with number and shown on this numbering system showing below this graph. This slide showing how the vertical pump to be installed in different operation, especially for inline pump, and the relationship between the shaft and the pump. The shaft is located here vertically and the impeller is affixed horizontally, and this suction flange and this discharge flange, the flow coming here and then go to the impeller eye and to be collected according to the rotational motion in this volute casing until reach to the discharge flange. And the motor here is affixed vertically, and the shaft, which is coupled with this safeguard to the impeller, which located here, and this is suction flange which distributes the flow to the suction eye of the impeller, and then the volute casing collect to the discharge flange the discharged flow from this pump, and this its nameplate and this its base as shown here. This slide also shows the construction of single stage inline pump in vertical arrangement with closed coupled motor, and how the motor is affixed to the impeller, and how suction flange is located here to direct the flow from the suction flange to the impeller eye, and then the impeller discharges the flow in the volute casing and discharges it from the discharge flange, which commonly with diameter with minimum size rather than the suction flange. So we can see here the suction flange from this side and go to impeller eye, and then according to the rotational motion we can collect the flow out of the impeller and then discharge it from the discharge flange, and this is a hook for the motor to handle the pump with its motor on the same base. This slide presents the preferred arrangement for measuring fire pump water flow with meter for multiple pumps and water supplies. water is permitted to discharge to the drain or to the fire pump water source after going through the meter. So all these suction sites from the suction tank supplying water to the main fire pumps, even 2 or 3 electrical driven or diesel driven, and the jockey pump. Each pump have its isolation valve of OS and Y gate valve located here, and then after the pumps we must use non-return valve or check valves which is located here, and then each pump have also its isolation valve of gate valve OS and Y. A bypass can be used to provide the test line for metering device with also two isolation valve for the metering device with straight lengths upstream and downstream the meter, and the flow rate to be discharged again to the water source or to the drain system, and the discharge line will be connected to the main discharge header which will be serve the building. Also the test line can be connected to the test header using hose valves, a number of hose valves, each can be metered for 250 GPM to meter the flow of each of these main pumps specially. And also we don't need to meter the flow of the jockey because it commonly of about 5% flow of this main pump of the fire pumping system. On this figure on the right hand side we can see the difference between the rotational direction of the shaft, even counterclockwise rotation when viewed from the driver end, or clockwise direction as shown in this arrow, this both arrow, in clockwise rotation when viewed from driver end, even for diesel engine available rotation, and for electrical motor. The suction flange and discharge flange will be switched according to this rotational motion, even counterclockwise rotational motion or clockwise rotational motion. And during design and the pump orientation inside the fire pump room, this direction of rotational motion should be considered, and the direction of suction and discharge flange should be adopted. The suction flanges, it's recommended or it must be towards the suction tank, and the discharge is directed to the discharge header which provide fire water to the building served with this pumping system. This slide shows typical installation of horizontal split case fire pump as per NIFPA 20 of when using horizontal split case fire pump supplied with supplied water from water supply tank under a positive head which is named static suction head. All the numbers are shown on the tableau on the right hand side, starting from number 1, above ground suction tank with this free water surface which provide static suction head above the center line of the pump. Then number 2, the entrance elbow and square vortex plate to prevent the vortex motion in suction side. Then number 3, suction pipe. Number 4, frost proof casing to prevent this valve chamber from ice in cold areas. Then number 5, flexible coupling for strain relief between the fire pump room and the tank and the valve chamber to take any strain which may be happen during installation or operation or sudden stoppage for the pump. We can use many, one or two flexible coupling to be located somewhere here to install easily the valve between these two fixed dimensions of the wall, which have been uh, designed by concrete. Then number 6, OS and Y gate valve, which will be located here with rising stem, showing that the valve is in open position. And then number 7, eccentric reducer, which have discussed before, and its right configuration of using it. Then number 8, suction gauge for pressure gauge on suction line. The horizontal fire pump is number 9. Number 10, the automatic air release valve, which affixed to the pump casing to prevent air pockets inside or air voids inside the pump casing. Then number 11, the discharge pressure gauge affixed to the discharge flange. Number 12, relief valve to be added especially for diesel engine to provide and to prevent any expected maximum pressure due to variation of diesel engine speed, and to be connected to the drain. Then number 13, the discharge check valve of swing check non-return valve. It should be mentioned that all system components such this OS and Y and relief valve and non-return valve or check valve and automatic air release, all should be listed according to UL and FM approved. And then we can use the bypass line to the test hose valve manifold with hose valves shown number 17, and then we can locate our indicating gate valve or indicating butterfly valve, which rarely used in fire pumping system. The commonly used is the gate valve of OS and Y, but here is installed horizontally instead of that on suction side, which is installed vertically. And then we can go to our fire stand pipe, which will be provide the fire water to the supply pipe for fire protection system to the served or to the protected building or area or zone. An additional drain valve or ball drip, also UL and FM, can be used here to ensure the cleaning and washing of this testing during testing, which is happen periodically, maybe weekly or monthly or annually. Also, a gate valve should be isolate this hose manifold from the system and should be normally closed, and this should be normally open to prevent the water in this direction as a common direction for the water which have been discharged by the pump after it has been supplied from this water tank through the suction line and go through the pump and then go through the valving system attached here and then go to the building through this fire stand pipe. A pipe supports like number 18 may be added and located in different locations to affix the suction line on this wall and on this wall, and also here in the fire pump room, and the discharge line on the fire pump room, and it should be affixed here and secured to prevent any damage which may be happen when the pump suddenly starts, and this with this rigid walls of concrete as commonly used in fire water tanks and fire pump room. This slide also continue how we can install a horizontal split case with different configuration, but similar to the previous slide, that we have the suction tank here and suction elbow with anti-vortex plate, and we can use anti-vibration flexible connection here, one or two, and then we locating this isolation valve of gate valve OS and Y here vertically, and then spacing, and then we use the eccentric reducer to adapt the suction diameter to the suction flange diameter, and we will use pressure gauge on suction flange, and this is the pump with its drive fixed on their concrete base separately, then the fire pump room base. Then the relief valve is located here to discharge the flow to the drain, or it may be back to the tank, suction tank in some cases. And then the swing check valve is located here, and this is its gate, and then the test hose to the fire department connection or hose valves with an isolating OS and Y installed horizontally, and the main OS and Y gate valve on the discharge line for each pump, which isolates the pump from the fire stand pipe to be supplied the fire water to the protected zone. Finally, we have this slide presents a summary of fire pump data, table 220, which is indicate all the recommended diameters in inch and their nominal minimum pipe sizes for different pump ratings starting from 25 GPM, 50, 100, 150, 200, 250, 300, 400, until 500, 750, 1000, 1250, 250, 1500, 2000, 2500. We can get, and also the flow is shown in liter per minute here in this column, which is equivalent to this GPM in bridge system as a pump rating. So for example, if we have a pump 500 GPM, so the suction line diameter should not less than 5 inch, and the discharge diameter line should be not less than 5 inch, maybe 6, and the relief valve should be not less than 3 inch. The relief discharge valve of the pump line, discharge line, not less than 5, which is equivalent to the same discharge line diameter. The meter device also the same, and the number of and the size of hose can be used two, each of 2.5 inch. Two hose valves can be used, each with 250 to cover this 500 GPM rating of this pump, and each one have a size 2.5. The number of hose header supply can be used 4. Here, if it used with 125 GPM per hose header in inch, the diameter of this header, which will carry out the two flow of these 2.5 hose valves, are 4 inch. If we have another pump size such as 1250, that means suction line diameter should not less than 8, and discharge diameter should not less than 8. The relief valve 6 inch, the relief valve of discharge line 8. The metering device can be used 6 inch, and 6 number of 5 or fire hose valves of 2.5 can be used, and their hose header supply line should be with 8 inch. We will continue this tableau for 3000 until 5000 in the next slide. So if we have a pump with 3000 GPM, we must use suction line not less than 12 inch and also discharge line. However, the relief valve should be 8 inch. The relief valve of discharge line should be the same size of discharge line, 12 inch, and the metering device should not less than 8 inch, and 12 number of hose valves of 2.5 inch each should be used and connected on hose header supply with not less than 10 inch in diameter. This slide is presented by Paterson horizontal fire pump manufacturer. To conclude, the accessories, all the accessories should be added to the horizontal and can be used as accessories with the horizontal fire pump, starting from its driver, which can be, this is the pump is located here. It can be connected to horizontal electrical motor, such it is horizontal pump, or diesel engine can be connected also, even for electrical motor or diesel engine. If we will use diesel engine, we will use a fuel tank to provide fuel supply and return from the diesel engine. Then automatic air release valve should be affixed to the pump casing, and the pressure gauges should be shown here on suction flange and discharge flange, discharge gauges or pressure sensors, and also eccentric suction reducer should be used on suction side to adapt the suction line diameter to the suction flange of the pump, and the isolation or S&Y gate valve should be provided here on suction line to isolate the pump from its water supply, which may be underground tank or overhead tank or from city main supply. Then on discharge line we can use commercial T from any pipe fitting provider, and elbows which will be connected to the relief valve to the waste cone using this enclosed cone flanged to the waste, and the main discharge line will be go through this side. After using concentric discharge increaser, when discharge T are not used, we can use this concentric increaser just downstream the the discharge flange of the pump to adapt between the discharge flange diameter and the discharge line diameter. Then we will use the check valve of UL and FM approved and go to the system after using the another isolation valve such as that one of OS&Y gate valve, which will be located here on this discharge line. And then we can also using the flow meter line with the two isolation valves. It's recommended to be of OS&Y gate valves to the waste or to the supply again, to the supply tank as mentioned here. And also we can use this test manifold for hose valves, a number of hose valves, and this will be can be connected to the drain valve as mentioned before, to the waste with ball valve for washing the line, and also we will connect with even flanged or the hose valve with nipple, which will be used here if it threaded type, to connect the hose valve with the hose valve header. So this slide is helpful to get all the horizontal pump accessories recommended by NFPA, and also the fire pump manufacturer of this slide is Paterson. This slide also by Paterson, the same system components, but it has shown in different configuration and different line diagram presentation, but the same components we can find similar to the previous slide. Discuss all the accessories required by pump manufacturer for horizontal pump configuration, especially for fire pumps used for fire pumping system. This slide also presented but by another vendor of fire pumps, Armstrong, also show the main components which will be used associated with the horizontal split case diesel driven pump to ensure its performance according to NFPA 20. This slide presents a third fire pump vendor, Aurora, and this slide presents a series of each fire pumps starting from single stage inline fire pump, which discussed before in previous slides, and also the vertical split case electrical fire pumps with vertical electrical motor but with split case, and then horizontal split case electrical driven, the electrical motor and shaft, and the split case with two pressure gauges, and automatic air release valve is connected here to the pump casing, and finally the end suction type with bare shaft without driver. Even we can connect diesel engine or electrical motor, horizontal electrical motor, and this is suction flange of the pump, and this is discharge flange of the pump, and the shaft is located this way horizontally as discussed before in the detailed construction drawing presented earlier in this lecture. This slide presents how we can install a unit of fire pumping system on one skid containing all the fire pumping system, such as electrical fire pump driven and diesel fire pump driven and jockey pumps, and its controller and suction headers and fuel tanks and discharge headers and all valve system as shown on this skid. One skid we can find here the controller of each pumping set. Three separately skids can be connected parallelly together, or can be used two or one according to the demand of water and the design of the system. This suction flange can be connected easily to the suction tank, and this suction side, this is the valve located vertically, and this is the testing return here, and the discharge line will be located here to connect the system, and this is the fuel tank. This is another one, consists of one diesel engine driven, and fuel tank is located here, and all the suction line components and discharge line components are affixed on one skid, and the fire pump controller is located here. This skid can be used for outdoor installation, especially for power plant fire pumping system. This slide also continue how we can install this skid discussed in the previous slide at outdoor location, in power plants or in factories where we haven't a location for a fire pump, and we can install it outdoor, and the tank will be located here. This is a suction tank which will provide the fire water required through this hose system to connect the suction line during operation, and also the discharge line we can return this water to the tank during testing process for this pump. And this is the fire pump controller and electrical MCCs for motor control center, which provides the electrical power supply to the fire controller, and all monitoring measuring instrumentation to monitor the performance of the pump in different operation range. This slide finally presents the pressure maintenance pumps, which is named Jockey Pumps, which is discussed before. Its flow rate is around 5% of the main pump, fire pump, with maximum about 50 GPM, or in some times we can use it as a maximum 100 GPM per pump. Each pump is a vertical with a vertical motor, as can be seen here, with multi-stage. The number of stage is detected according to the head required. The head of this pump should be higher slightly than the main fire pump head. For example, if we have the main fire pump head is 300 feet, so we can get this jockey pump head is 330 feet or 320 feet, about 10% increasing, or 20 feet, 30 feet higher than the main pump head in feet or in meter also. The jockey pump have its controller standing alone. This slide also continue the construction of pressure maintenance pumps, jockey pumps, showing the suction flange and discharge flange, and the shaft is located here, and affixed on it the number of impellers according to the required head per each stage to get the total head of this pump, which may reach 300 feet or 350 or 400, as discussed in the previous slide. This is an nameplate, this is the motor of the pump, and this is the pump casing of stainless steel, and this is the base to be affixed here with bolts on the same base of the main fire pumps, or in between the electrical driven and diesel driven fire main fire pumps. And this is the power supply connection, the box to enter the cables to feed this electrical motor from the controller, the flow coming from the suction side and go through the first impeller, and then second impeller, third impeller, fourth impeller, and until the latest stage, and then to be collected and go through the discharge of the pump from the other side of the suction. Also, this figure showing how to connect the jockey pump in parallel with the main fire pump with its isolation valve of OS and Y and non-return valve separately, and this is the main gate valves of the main pump and non-return valve, and this is the test header for the hose valves, which discussed before in the this lecture in early slides. So we have now finalized the construction of fire pumps of horizontal type and jockey pump, and we will continue the vertical pump and the main components such as valves used, details in the third lecture of this fire pump set lectures, in lecture number 8. Thanks for watching.